Last question then. Lines L1 and L2 have vector equations. There you go, you can leave them. Respectively, where T and S are parameters and A is a constant. Given that the lines are perpendicular, find the value of A. Okay, we haven't kind of recapped vectors, but we do know that we have this thing which some people call the dot product, some people call the scalar product. If you multiply these two vectors together in this way, then you get the length of A times the length of B times the cosine of the angle that's between them. And it's the angle, the leading angle that's between them. So whatever direction they go in, the angle that they would make. That means that if we rearrange that, or in fact we can leave it like that for now for what we're thinking about, given that they're perpendicular, if they're perpendicular, then the angle theta is 90 degrees, pi by 2 radians. And the cosine of 90, or the cosine of pi by 2, is 0. So that's 0. So all of that's 0. So if they're perpendicular, then their dot product, A dot B, is equal to 0. That's an important result. So this says that these two vectors are perpendicular. Now when we talk about their direction, the only bit that matters is the bit that's multiplying the parameter. Basically, with a straight line, when you write the equation of a straight line, the first bit tells you how to get from the origin to the line, and the second bit tells you, once you're on the line, which direction are you going. And that's how the lines are constructed. The first bit is how to get from the origin to it, the next bit is its direction. So when we're talking about them being perpendicular, the bit that matters is their direction. So really, what it boils down to is this part 1 is telling us that if we find the dot product of 2A1 and 2 minus 6, if we find the dot product, because they're perpendicular, that must be equal to 0. And once we've recognised that that's all the question is telling us, we just have to work out this dot product. You do it by multiplying the two I bits together, add in what you get when you multiply the next bit, the J bits, and adding that to the product of K bits, giving us 4 plus 2A minus 6 is 0. In other words, 2A equals 2. If they're perpendicular, A is 1. That was it. It was that simple. But now the question changes again, and it tells us that actually A isn't 1, given instead that L1 and L2 intersect. Find the value of A. Well, if they intersect, that means there is, it's like simultaneous equations. There is some point where the two lines cross. At the point of intersection, the two equations must be equal to each other. It's like having two straight lines, y equals mx plus c, and you put the two y bits equal to each other. That's the point of intersection. So we're saying that the first one, 0, 1, 1, plus t times 2a1 is equal to 3, 0, minus 1 plus s 2, 2 minus 6. I'm working in column vector rather than ij and k's because I just find it easier. But it's entirely up to you, it's personal choice.
For a question like the first part of the question, can we just convert to column vector?
Yeah. It doesn't matter, they're interchangeable on the two forms. Okay, now what we're saying here is if this is true, then each of these three lines are the same. We've got the same I components, the same j components, and the same k components. So we set up equations involving those. We look at the I bit, the top line, and we ask ourselves the question, how many i's have we got? 2. It's 2t equals 3 plus 2s. That joke has often gone down badly, but never quite that badly. Then we've got the j components. We've got 1 plus AT is 2s. And we've got the k components. 1 plus t is minus 1 minus 6s. Shh. Now, each of these three things must be true because they intersect. Normally, when we're trying to decide whether lines intersect or whether they skew, we don't know that three things are true. We have to either show that they are or they're not. But they've told us that they intersect, so these three equations have to be consistent. Let's call them 1, 2 and 3. Equations 1 and 3 only involve s and t, so they look like a good place to start. Equation 3 tells me that t equals minus 2 minus 6s. And so in equation 1, that tells me that twice that is 3 plus 2s. So minus 4 minus 12s is 3 plus 2s. So I think I've got, have I done this right? Oh yeah, it's okay, isn't it? I've got 14s is minus 7, so s is negative half. Which means that t is minus 2 plus 3, so t is 1. Is that right? If I put minus a half into that, I've got minus 2. 6 times minus a half, that'll make it plus 3. So that's right. And so, because they intersect, these two values must satisfy equation 2. In equation 2, I have 1 plus a times t is 2s. So I have a equals minus 2 as my value at the point of intersection. And finally, if that's the case, I want to find the angle between the two lines. Remember the first thing we did in this question? I wrote down this. I wrote down that. It's also helpful to remember the rearrangement of that. It says that cos theta is a dot b over that. And now what we're dealing with here is the angle between these two vectors. When you're talking about angles, you focus on the bit after the parameter. So we're saying the two vectors that we're interested here are 2, a is minus 2 now, so it's 2, minus 2, 1, dotted with 2, 2, minus 6. And the modulus of a vector, the magnitude of a vector, that is the square root of each of the components squared, added together. It's like Pythagoras' theorem extended into 3 dimensions. So here we've got that the cosine of the angle is, what's that, 4 minus 4 minus 6. So it's minus 6 over that's 3, and that's root 44. Okay, now, if we do inverse cos of that, then we get our answer. Inverse cos of minus 6 over 3 root 44. And it gives us theta is 107.5 degrees. It didn't say find the acute angle, so I'm guessing that that's what they want. Yeah, they're accepting 107 or 108 as the angle. They're also accepting the acute angle if you wanted to find the acute angle. No, that's normally it says find the acute angle. In this